Hey, this is Tom from Tutor Bros. Today we're going to go over the segment addition postulate. The segment addition postulate states that if we have three collinear points, or points on the same line, the segment from the first to the second point and the segment from the second to the third point will always add up to the length of the entire segment. Now, algebraically, we can represent that as segment AB plus segment BC is equal to segment AC. So we can use this postulate to solve all different kinds of problems, and we'll do a few of those together right now. So let me just erase these little squigglies, and we'll get started. All right, number one, we will say that segment AB is equal to 17, and segment BC is equal to x plus 4. And then segment AC is equal to 36. Alrighty, so how do we use this information to solve for x? That would be our task in this first one. Well, we just take the values of the segments, plug them into the equation below, and then solve for x. So if AB is equal to 17, then we can replace that down here with a 17, plus BC, which is represented by the expression x plus 4, and that would be equal to the entire segment, the length of which is 36. So now we just have a standard linear equation. We can combine our like terms and then just solve for x. So on the left-hand side of the equation, I can combine the 17 and the 4 to get 21. So that would be x plus 21, and that still equals 36. And then to solve for x, I just subtract 21 on both sides. So x would be equal to 15. So there you go, we've solved for x. The other thing you might be asked to do is you might be asked to find the length of whichever segment has the variable in it. In which case, all we do is just go back and retrieve the expression with the variable. So segment BC was represented as x plus 4. But we know what x is now. It's 15, so we can just plug that in for x. So 15 plus 4 would be equal to 19. So depending on what they're asking you to solve for, you may be asked to solve for the variable, or you may be asked to find what the length of the segment is, or both. So just be careful about what you are being tasked to do. All right, so that is one problem down. Let's erase this and we'll go back and start over. Let me erase this up here. Okay. All right, number two, we'll say that AB is equal to 2x plus 3. BC is equal to 3x minus 1. And AC is equal to 47. Now in this one, we have a variable in both the first and the second smaller segments. But the process is still the same. We would just substitute those expressions into the equation below and solve for x. So AB is 2x plus 3 plus BC, which is 3x minus 1, the sum of which is equal to 47. Then we combine our like terms again. So the 2x and the 3x on the left-hand side, I can combine that to get 5x. And the positive 3 and negative 1, I can combine that to get positive 2 or plus 2, which equals 47. Then I'll subtract 2 on both sides. So 5x is equal to 45. And then I divide both sides by 5 to get x equals 9. So there you go. We've solved for x again. And let's go ahead and go back and plug 9 in for x to find out what the length of both AB and BC is. So AB was originally represented as 2x plus 3. So we'll plug the 9 in for x. So that would be 2 times 9 plus 3. 2 times 9 is 18, plus 3 is 21. Right? And then we'll do the same for BC, which was originally represented as 3x minus 1. So 3 times our x we know is 9 minus 1. 3 times 9 is 27, minus 1 is 26. So segment AB is 21, segment BC is 26, and that checks out because if we add the two together, we will get the length of the entire segment, which, as you see up here, is 47. All right, 2 down, 1 to go. Let me erase all this again. Okay. Nerve-wracking doing all this erasing. Don't want to erase something that I want to leave on the board. Okay. Almost done. There we go. Alrighty, last one. AB this time is going to be 3x plus 5. BC is 8x plus 1. And AC is going to be 13x. Now in this one we have a variable not only in the two smaller segments but in the entire largest segment of AC. But once more, process is still the same. We just plug in the expressions in the equation below and go from there. Alrighty, AB 3x plus 5. BC is 8x plus 1. And AC is 13x. Alright, on the left-hand side of the equation, we'll combine our like terms. 3x and 8x is 11x. 5 and 1 is 6. The sum of which is still 13x. Okay, then we can subtract 11x on both sides of the equation. So 6 is equal to, then 13x minus 11x is 2x. Then to isolate for x, we just divide both sides by 2. So 3 is equal to x, or x is equal to 3. Now in this one, let's see if we can find the length of AB, BC, and AC. All right, so we'll start with AB, which was originally expressed as 3x plus 5. So it's 3 times, remember our value for x is 3, plus 5. 3 times 3 is 9, plus 5 is 14. Okay, then BC, so that's 8x plus 1, so 8 times 3 plus 1. 8 times 3 is 24, plus 1 is 25. Now if we wanted to find AC, we could just add AB and BC together, but just to make sure, we will take the original expression that represented the length of AC and then plug in our value for x. So AC was 13x, so we'll do 13 times 3, and 13 times 3 is 39. So we'll check that just to make sure. AB is 14, BC is 25, and if we add those two together, we do indeed get 39.